Hello, my phenomenal viewers, and welcome on today's episode. On today's episode, we are going to be answering this GCE Advanced Level 2023 question 7 Roman 2. And the question reads, given the periodic function f with period 6, where f of x is equal to x minus 2 for 2 lesser than or equal to x and x lesser than or equal to 5, and f of x is also equal to negative a half x plus 4 for 5 lesser than x and x lesser than or equal to 8. The A part of the question says, show that f of x is not continuous at x is equal to 5. B, find f of 19. C, sketch the graph of y is equal to f of x in the interval -1 lesser than or equal to x and x lesser than or equal to 8. So as you can see, the question is under periodic function. Now, before we dive into answering this question, I would like to give a brief introduction or a brief synopsis on what a periodic function is all about. So when we say a function is periodic, it simply means that the values of this function repeat themselves after a particular interval. That is the graph of the function, which is simply the graphical representation of the points that are found on the function, repeat itself after a given interval. So in this case, the period of the function is 6. So it shows that every after 6 units, each point repeats itself. Every after 6 units, each point repeats itself. So that is what a periodic function is all about. It is a function whereby the values of that function repeat themselves after a given interval. So coming back to the question, we've been given this function f of x. It is given in two parts. So f of x is a piecewise function since it contains two parts and also two different domains. So f of x is equal to x minus 2 for 2 lesser than or equal to x and x lesser than or equal to 5. Then it is also equal to negative a half x plus 4 for 5 lesser than x and x lesser than or equal to 8. So we need to show that f of x is not continuous at the point where x is equal to 5. So how do we do that? Solution. I hope that you've already grabbed a pen and a book to join me as I provide a solution to this A part of the question. So show that f of x is not continuous at the point where x is equal to 5. Now, what you need to know about continuity at the point, for a function to be continuous at a point, this shows that the limit of that function as x approaches that point from below it must be equal to the limit of that same function as x approaches the point from above it, which is equal to f of x. So mathematically, for a function to be continuous about a certain point A, then this condition must hold true, which is the limit as x approaches the point A from below of f of x must be equal to the limit as x approaches the point from above it of f of x, which is also equal to f of a. Once this condition holds true, then we conclude that the function is continuous about or at the point where x is equal to a. If this doesn't hold true, then we conclude that it doesn't continue about the point where x is equal to a. So in this case, our x is a point 5. So we are going to see, or we are going to find out whether this function has a limit that is the same as this, that is from below the point 5 and from above the point 5. So from below the point 5, we are going to make use of this first part of the function, since this is where the function approaches 5 from below. Remember, x is what? Less than or equal to 5 here. So it shows that it is approaching 5 from below 5. Then here, x is what? Greater than 5. So it is approaching 5 from above 5. So from below 5, we are going to make use of this function. From below 5, we are going to have limit of x minus 2 as x approaches 5, which is equal to 5 minus 2, and this gives me 3. So it shows that the limit of f of x as x approaches 5 from below is equal to 3. And this is the same as f of 5 because 5 is found in the domain of this first part of the function. So for us to obtain f of 5, we simply substitute the value 5 in here, which still gives us 3. Now we need to determine the limits of this same function as x approaches 5 from above it. We are going to make use of this second part of the function. So we are going to have limit as x approaches 5 of negative a half x plus 4, and this gives me negative 5 on 2 plus 4, and this is 1.5. Since this is 2.5 plus 4, that is negative 2.5 plus 4, which gives me 1.5. So this is the limit of the function as x approaches 5 from above it. So this is the limit of the function as x approaches 5 from below it, and this is the limit of the function as x approaches 5 from above it. We can see that the two values are not equal. So since 3 is not equal to 1.5, hence f of x is not continuous. It's not continuous at x is equal to 5. Since the limit of the function as x approaches 5 from below it, which is 3, is not equal to the limit of the function as x approaches 5 from above it, which is what? 1.5. So since these two values are different, we conclude that the function is not continuous about this point where x is equal to 5. The B part of the question says find f of 19. I hope that this A part of the question has been well understood and assimilated. So this is the rule or the condition that must be satisfied whenever you are asked to prove for continuity at a point. So this condition must be fulfilled. If this condition is not fulfilled, then you conclude that the function is not continuous at that point. Now we need to determine f of 19. So the B part of the question says f of 19. Okay, now looking at the two domains given to us, we can see that 19 is not found in any of these domains. 19 is not found in any of these intervals given to us. But we know that f of x is a periodic function, and like I explained, it shows that the values of this function repeat themselves after a particular interval. So since it has a period of 6, it shows that each value repeats itself after 6 units. So what we are going to do here, since 19 is greater than the highest value found in the second domain, we are going to be subtracting 6 from 19, and we are going to stop when we are going to have a value that lies within any of these two domains. So what this means is, since f of x is a periodic function with a period 6, this shows that f of 19 is the same as f of 19 minus 6. 19 minus 6 gives me 13, which still doesn't lie within any of these two intervals. So I'm still going to simplify it further. I'm still going to subtract 6 from 13. So I'm going to have 19 minus 6 minus 6. This gives me f of, this is 19 minus 12 now. This gives me f of 7. This gives me f of 7. So this simply shows that the value that this function has when x is equal to 7 is the same value that the function has when x is equal to 19. So automatically, f of 19 is equal to f of 7. So I'm just going to look for the part of the function that I can substitute this value of x, which is equal to 7, based on the different intervals given to me. So 7 lies within this interval. I'm going to make use of this second part of the function. So f of 19 is equal to negative 7 divided by 2 plus 4. Negative 7 divided by 2 gives me negative 3.5 plus 4. This gives me a half. This gives me a half. So this shows that f of 19 is equal to f of 7. F of 7. So f of 19 is equal to f of 7, which is equal to a half. So this is how you obtain the value of f of a certain x that is not found in any of the intervals given to you. You simply either subtract 6 from it, or you maybe add 6 from it. If maybe the value given to us was lesser than 2, we are going to be adding 6 to it up to when we have a value of x that lies within any of these two intervals. So if the B part of the question has been understood, let us now move to the C part of the question, which states that sketch the graph of y is equal to f of x in the interval -1 lesser than or equal to x, x lesser than or equal to 8. So for me to sketch this graph, I need the different values of f of x, which are going to serve as the values of y, the values of y. So I'm going to have x, then y. My x is from -1 up to 8. So I have -1, 0, 1, 2, 3, 4, 5, 6, 7, and 8. So these are the different values of x. Now I'm going to determine the corresponding values of f of x, which is the same as y. So when x is equal to 2, I'm going to have 0. When x is equal to 3, I'm going to have 1. When x is equal to 4, I'm going to have 2. When x is equal to 5, I'm going to have 3. I'm going to have 3. Then when x is equal to 5, I'm going to have a different value for the second part. So since this function is not continuous about the point where x is equal to 5, it has what is called a jump discontinuity. It has a jump discontinuity at the point where x is equal to 5, since it has two different values at the point where x is equal to 5. So it therefore means that the function has a jump discontinuity. So when x is equal to 5 here, I'm going to have 1.5. So you see that I have two values. When x is equal to 5, 3, and 1.5. When x is equal to 6, I'm going to have 1. When x is equal to 6, I'm going to have 1, since this is -3 plus 4. When x is equal to 7, I'm going to have 0.5. I'm going to have 0.5, which is a half. And when x is equal to 8, I'm going to have 0. When x is equal to 8, I'm going to have 0. Now for me to determine the value of f of 1, I simply add 6 to 1 to see where I'm going to land. When I add 6 to 1, I'm going to have 7. So it shows that when x is equal to 1, it is the same value that we are going to have when x is equal to 7, which gives me what? Negative 0.5. Negative 0.5. Then for 0, I'm still going to add 6 to it. I'm going to land at 6. And the value of f of 6 is 1. Then for -1, I'm still going to add 6 to it. That gives me what? 5. So -1 has two values as well. We have 3 and 1.5. So at the point where x is equal to -1, we still have that jump discontinuity at that point. So these are the different values of x and the corresponding values of y. Now with these different values, we will be able to plot the graph of y is equal to f of x. So let us plot the graph together. So this is my y, this is my x. I have 1, 2, 3, 4, 5, 6, 7, and 8. I have -1. I can extend it up to -2 as well. Then for my y, I have the highest value to be 3. So I'm going to have 1, 2, 3, 4, and the lowest value to be 0. So I'm now going to plot the graph. So I'm going to start from 2. Let me start from the interval given to me, the first interval given to me, which is what, from 2 to 5. When x is equal to 2, y is equal to 0. So 2, 0. So I'm shading it. I'm shading the circle because 2 is found in the domain. When x is equal to 3, I'm going to have 1. For y, 3, 1. So 3 is still found there. I'm shading it. When x is equal to 4, I'm going to have 2, 4, 2. So I'm going to shade it as well. 4 is found in the domain. When x is equal to 5, I'm going to have what? 3. And 5 is also found there, so I'm going to shade this 5, 5 and 3. I'm going to shade it. So this is the first part of this function, and it is a straight line. So I have a straight line like this. I have a straight line like this. So this is the first part of this function. Now the second part of the function, when x is equal to 5, I have what? 1.5. Well, now since 5 is not found in the domain of the second interval, 5 is not found in the second interval, then I'm going to use what? An open circle. Since here x is strictly greater than 5, or 5 is strictly lesser than x. So 5, 1.5. 1.5 should be midway between 2 and 1. So I'm going to have an open circle here, indicating that 5 is not included in that domain. Then when x is equal to 6, I will have 1, 6, 1. When x is equal to 7, I have 0.5. 0.5 is midway between 1 and 0. So 7.5, something like this. So if you are using with the graph paper, you are going to have a graph that is more accurate. So it is also a straight line like this. So this is the second part of the function. Remember that the function has a period of 6. So whenever we've plotted 6 points, we now need to start repeating each point. So that is the meaning of this function having a period of 6. So the next point that we need to plot is the point 8. When x is equal to 8, we are going to have what? 0, which is simply the repetition of the value of f of x when x is equal to 2. Since we will add 6 to 2, we are going to have 8. So f of 8 is 0. So that is the point 8, 0. Now we now need to extrapolate backward. When x is equal to 1, we have 0.5, 1, 0.5, have 1, 0.5. When x is equal to 0, I have 1, 0, 1. When x is equal to -1, I have 2 values as well. So it shows that at this point there is also a jump discontinuity. So for this other interval, I'm going to have an open circle for 1.5. So 1.5, I'm going to have an open circle for -1, an open circle. So I have this part of the function, which is just the repetition of this other part. So if you're using the graph paper, you're going to have a graph that is more accurate. Then for this same -1, I'm going to have the point 3 as well, which is closed. So this 3 is closed here. So since the question asks us to sketch the graph from -1 up to 8, so you can end here. But if you have to continue, you simply extrapolate backward. For -2, when you add 6 to -2, you are going to land at 4, and f of 4 is what? 2. So it shows that -2 goes with 2. -2 goes with 2. For -3, you add 6, you are going to land at 3. F of 3 is 1, so it shows that -3 goes with 1. Then for -4, when you add 6 to -4, you're going to land at 2, and 2 goes with 0. So at -4, we are going to have 0 here, and you can now link it. You link the different points. So you can see that this is just a repetition of this other graph, or of this other straight line. So this is how the graph of f of x looks like from -4 up to 8. So this is how you go about answering this question on the periodic function. And if you loved this video, please help me and share so that I can get to many students as possible. And if this is also your first time coming across any of my videos, please do not hesitate to either follow me or subscribe, so that whenever I upload videos like this one, you will be notified. And thank you for watching. Stay blessed. And if maybe you do not understand any part of the explanation that I gave, you can still type in the comment section for me to explain further. Stay blessed once more.